So how can you determine whether a relation is a function just by inspecting its graph? We use what's called the vertical line test. The relation is a function if and only if no vertical line intersects its graph more than once. So what does that mean? If I look at this function right here, I should be able to draw a vertical line at any point and never hit more than one point on the graph. So I should be able to only ever hit the graph one time when I draw a vertical line. So since I only ever hit it one time, I say this passes the vertical line test. And if it passes the vertical line test, then yes, it is a function. Now let's compare that to the next one. What I said was that no vertical line can intersect the graph in more than one point. So I drew a vertical line that hit the graph in two different points. So no, not a function. Pretty easy stuff, right? How about this one? One thing to know about these types of problems is you can always assume that there are arrows on the end unless I actually draw points. So if I look at this, I can draw vertical lines everywhere and I will never hit more than one point. So this one is a function. Let's look at this one. This is a little bit deceiving because it looks like this might go straight up and it looks like might pass or might fail the vertical line test. But a parabola is a figure that continuously gets wider and wider and wider ever so slightly. So a parabola will always pass the vertical line test. So yes, this is a function. Obviously, the circle is not a function, right? Because it hits the graph in more than one point. So not a function. And then this one is could also be deceiving. So I want to make sure I point it out. This is called a cubic function, which you'll learn later. But this also goes ever so slightly out as it goes up. So this does pass the vertical line test, and therefore it is a function. Now I'm going to put you to the test and ask you to decide if the following two on your paper are functions.